6.5 proportionality theorems. So triangle proportionality theorem. If one or more lines is parallel, one or more lines intersect two sides of a triangle and are parallel to the triangle's third side, then the two intersected sides are divided proportionally. So these two lines are parallel. That means that it divides this proportionally. So like I could set up a proportion of 1 over 3 equals 2 over 4 if I'm labeling those sections instead of writing the SU over QT. I could also set that up as 1 over 2 equals 3 over 4. That would be congruent. I could flip those the other way because in either case I'm multiplying the 1 and the 4. And then this is just the converse of this. So if one or more lines intersect two sides of a triangle proportionally, then the lines are parallel to the third side of the triangle. So what this is saying is, if I know that this side over this side is equal to this side over this side, so if I can write up this proportion, and it's true, then that means that this side is parallel to this side. Okay? So it's just the converse, it's just the flip. And then theorem 6.6, if two or more parallel lines intersect two transversals, so we have 1, 2, 3 parallel lines, and we have two transversals, this guy and this guy, then the two transversals are divided proportionally. Meaning I can set up proportions there, okay? Go ahead and try numbers 1 through 6 real quick. Figure out which side is missing on those. So GC over CF is equal to what over DB? What do you guys say? GD is correct. Number 2, A to F over F to C is equal to something over B to D. What would that be? I'm sorry? Yeah. Number 3, C to D over F to B is equal to G to D. Be careful on this one. It's not BD. It would actually be GB. So the reason why this is different, so we can do side over side and side over side, but when we're talking about the base, we're talking about a whole length on the base and not just a part of the length on the base. So we would have to go with that whole side. So think of that more as two triangles, like this triangle's base over side, this triangle base over side. Does that make sense? That one's tricky. Okay, A to E over C to D is equal to G to E over what? Oh, wait. Oh, sorry. I was looking at A to E. A to E is this big length over C to D is equal to G to E over what? Yep, G to D. That side length over there for the smaller triangle. Okay, F to G over A to G, so medium triangle side over large triangle side is equal to F to B, medium base, over what? A to E. Yep, the large base. And then the last one, G to D over G to E, so small side over long side is equal to something over the long base. What would go on top? C to D. Okay, so looking up here, if we're just talking about pieces of the triangle, we can do piece over piece equals piece over piece. But if we talk about like this guy, the base of the triangle, it has to be over its entire side. And then this base over its entire side, okay? That's where it may get confusing. Use the given information to determine if this guy is parallel to this guy. So that would be going up to theorem 6.5, the converse one, which states that if I can write a statement of proportionality that's true, then those two lines are parallel. So if I could write 6 over 5 is equal to 9 over 7.5, then it would be true. So take both fractions and turn them into decimals. What is 6 over 5 as a decimal? Yep. And what's 9 over 7.5 as a decimal? What did you say? I'm sorry. 1.2. So are they proportional? Yes. So yes. Guys, I want you to look at this also. Another way you could do this is you can actually cross multiply. What's 9 times 5? And then on your calculators real quick, do 6 times 7.5 for me, please. Okay. So if when you cross multiply they do equal one another, then that also means that they are proportional. Okay? So 2 ways to check that. All right, next page, guys. Determine the length of each missing segment. I want for you to try this on your own. Let's see how well you can do on this. See, so on these, I would like to set up a proportion to solve. Tell me a proportion I could set up for B to C. What over what equals what over what? We'll call B to C X. Yeah. Possibly, but if you're finding X that way, then you're going to be given, it's going to give you that entire length, which then you could subtract off the 5 or the 6, right? But if you do 10, it's the whole length. You can do that, and it's going to give you A to C, and then you subtract off 6. Is that what you did? Okay, that's fine. Is there another way I could solve this? Perfect. 5 over 6, so this side over this side equals 5 over X. Well, look at that. What would X have to be, guys? Yep. So if you did it the other way, you would have gotten 12. Subtract off the 6, and you get 6. Okay. Next one, C to D, this guy right here. So what could I set up? Someone new. What could I set up there? We're going to call C to D Y. What over what? What piece over what piece equals what piece over what piece? We're not talking about a base, so we could do the little pieces on the side. Yeah. Perfect. So what she did was 6 over 5, so this side over this side, that piece over that piece, is equal to this piece over this piece, y over 7. And then we cross multiply and we get 5y equals 42, right? So y equals how much? Yep, perfect. Okay. F to C. Okay, so now F to C is across the bottom. So yes, now we're going to have to use whole pieces of sides, okay? So I'm going to label F to C as Z. So what over what equals what over what? Oh, and look, they gave me 15. That's a whole piece across the bottom, right? So that's what I'm going to compare with that Z. So what should I put here? What over what equals what over what? I'd like someone new. Yep. Yeah, so did you do this side? Yes. So 20.4 over 15 equals 12 over that letter. What's my only concern that I'm going to say on that? Yeah, exactly. If I didn't get my Y or my X correct, am I going to get this correct? So could I come to the other side instead? Because those were all numbers that they gave me. So what is that side length over there? So 17 over, what would I put it over? Sure, I can do that. So 17 over 10 equals 15 over, yep, that works. I could have also done 17 over 15 equals 10 over Z, but again, multiple ways we can set this up. Cross multiply. 17Z equals 150. Divide by 17, and what do we get there? Yeah. It's keeps going, right? It's actually 8 and 14/17, because I think that's a funky decimal. Same thing. Okay, last one, G to B. So G to B is right here. I'm going to call that A. So what could I do here? What over what equals what over what? So that's a triangle bottom, so I have to use the triangle sides on that one. Awesome. Good. The whole length over the whole bottom equals the side length over the side bottom, right? Cross multiply, and I get 17A equals 75. Is that right? Divide by 17, divide by 17, and I get A equals 4 and 7/17. What do you notice about these two numbers? My answers for Z and my answer for A. A is half the Z, which should make sense, guys, because look, A has a side length of 5, Z has a side length of 10, so didn't we just double the side length? So that should double the base, right? Okay. Okay, one more thing on this, guys. Theorem 6.7, triangle, angle, bisector, proportionality theorem. If a segment or ray bisects an angle of a triangle, so this C to D is bisecting this angle C because this angle is equal to this angle. Then the angle bisector divides the opposite sides into two segments that are proportional to the two sides forming the bisected angle. So this side with this side are proportional with this side and this side. Okay? Because this is an angle bisector. So, what we are going to do here is we are going to solve for x, which will also give us C to D, right? So, remember, this side over this side is equal to this side over this side. So let's set up my proportion. So what do you think? What over what? How will I label this C to D? Perfect. 13 minus x over what? 16. Yes, you could do x, that's fine. Equals, if I put it over 16, what goes first on the top on the next one? There we go. We cross multiply. 16 times x is 16x. 13 times 10 is 130. 10 times x is minus 10x, right? I'm going to start moving stuff, so I need to add the 10x to both sides, so I get 26x equals 130. Divide by 26, divide by 26, and what do I get there? So x equals 5. How much is D to C then? You just take that 13 minus that 5, right? Good job, guys. Bueno. Okay. What you have now is you have a Schoology, you actually have two Schoology assignments. They are labeled 6.5 and 6.6, I think. They're mislabeled, so we haven't actually gotten to 6.6. We'll do that Monday. But the 6.6 in Schoology is a concept that you guys have already learned. So you can do 6.5 and 6.6. Those are both things that you have already learned.